Hello everyone, welcome back to Power Quality Lecture Series. In this video, we are going to discuss about power quality standards. So, power quality standards are needed in the power quality industry. Power quality industry recognize that power quality standards are critical to the viability of industry. So, therefore, the stakeholders in the power quality industry have developed several power quality standards in recent years. They recognize that the increased interest in the power quality has resulted in the need to develop corresponding standards. They realize that increased use of sensitive electronic equipment, increased applications of nonlinear devices to improve energy efficiency, the advent of deregulation, and the increasingly complex and interconnected power system all contribute to the need for the power quality standards. Actually, these standards set voltage and current limits that sensitive electronic equipment can tolerate from electrical disturbances. And also, utilities need standards that set limits on the amount of voltage distortion on their power system can tolerate from harmonics produced by their customers with the use of nonlinear loads. So, also that in case of a deregulation also increases the need for the standard so that they can ensure the quality of power. So standards are important in a power quality of industry. Standards allows utilities to provide different levels of power quality services. Several national and international organizations have developed power quality standards. There are many number of different organizations that set power quality standards. So we can go through some of the organizations and their standards. These are power quality standard organizations uh, inside the US and outside US. Uh, I hope all of you remember, all of you know these organizations like Institute of Electrical and Electronics Engineers, IEEE. Then ANSI, that is American National Standards Institute. Then National Institute of Standards and Technology, NIST. National Fire Protection Association, NFPA. National Electrical Manufacturers Association, NEMA. Then EPRI, that is Electric Power Research Institute, and UL, that is Underwriters Laboratories. These are the organization that they developed power quality standards. These are the organization based on US. Outside US, the important standard organization is IEC, that is International Electrotechnical Commission. Also, there are Euro norms and ESCOM for South African standards, etc. are there outside US. So, in mainly we are depending upon IEEE standards and ANSI standards. In fact, so let us go through IEEE guidelines, standards, and recommended practices in power quality. IEEE power quality standards deals primarily with the power quality limits of disturbances at the point of common coupling, or otherwise known as PCC. So mainly power quality IEEE standards are dealing with the disturbances at the point where the utility connects to the customer or end user. And the IEEE power quality standards have great impact in electrical utility industry, but actually this organization lacked the official status, especially in America. Their official standard organization is American National Standard Institute, ANSI, which have the responsibility to adopt the standard for United States. So let's move on to different IEEE guidelines relating to the various things in power system, in general power system. So this can be numbered here, like IEEE 4 that deals with the standard techniques for high voltage testing, IEEE 100 the standard dictionary for electrical and electronics engineering, IEEE 120 that is the master test guide for electrical measurements in power circuits, IEEE 141 is dealing with the recommended practices for electric power distribution for industrial plants with the effect of voltage disturbance on the equipment within an industrial area. IEEE 142 recommended practices for grounding of industrial and commercial power systems. IEEE 281 that is standard service condition for power system communication equipments, and the IEEE 519 that is what is actually dealing with the power quality recommended practices for harmonic control and reactive compensation of static power converters. So IEEE 519 standards is basically dealing with the guidelines of power quality or harmonic standards. IEEE 539 standard definitions terms relating to the corona effect. Then IEEE 859 that is standard terms for reporting and analyzing the outage occurrences, etc. So these are, I just put this slide here to understand there are various guidelines provided by IEEE in the various areas, and here we are interested in the power quality standards only. And the IEEE power quality standards, some of the IEEE standards are given here. Actually, these are put forwarded by Power Quality Standards Coordinating Committee of IEEE. Mean power quality standards, the number is IEEE 1159. So this 1159 have three categories: IEEE 1159-1, IEEE 1159-2, and IEEE 1159-3. The first one is dealing with the entire guidelines. IEEE 1159 is dealing with the monitoring of electric power quality. In that three categories, IEEE 1159.1 that is the guide for recorder and data acquisition requirements. Then IEEE 1159.2 dealing with the power quality event characterization, and 3 dealing with the data file format for power quality data interchange for the analysis purpose. And IEEE 1 P1564 that is dealing with the voltage sag indices standards. Then 1346 is dealing with the power system compatibility with the process equipment. IEEE P1100 is the guidelines to power and grounding electronic equipments. IEEE 1433 is the power quality definitions. IEEE P1453 is the voltage flicker standards, and IEEE 519 that I already told that is dealing with the harmonic control in electrical power systems. So in this slide you can see the IEEE different power quality standards that is given by different organizations. Like grounding, in case of a grounding, IEEE 446, 141, 142, and ANSI 70, all these are giving various standards regarding the grounding procedures. Then powering, surge protections, harmonics, disturbances, etc. So many things are there: life mitigation equipment, telecommunication equipment, noise control, utility interface, monitoring, load immunity, system reliability. So all these things have relevant standards that is listed there, that is provided by IEEE or ANSI or NFPA or UL, etc. So I have given in order to give a idea about various standards in the various topic. And here in this slide you can see that IEEE power quality standards, in a way you can see the first waveform, you can see that is the impulsive transients, and the various standards are given under different domains like disturbance sources are defined in ANSI or IEEE C62.41, and its effects of impulsive transients are given by ANSI or IEEE C62.45, and its mitigation standards is given by UL 1449 or IEEE 1100. So likewise, for a single event like impulsive transients, the guidelines or standards for disturbance sources and its effects and also its mitigation methods are available. All these three general standards are different, and for a particular harmonics power quality issues in your system like impulsive transients, you can refer all these standards. You can refer in order to identify the sources, you can refer IEEE 62.41. Its effects are given in IEEE 62.45, and its mitigation methods are given in IEEE 1100. So likewise, oscillatory transients are given. Here also it is listed its disturbance sources standards, effects standards, and mitigation standards. Also sag as well, its disturbance sources are given by IEEE P1346, and its mitigation is given in IEEE 446, IEEE 1100, etc. So likewise, I have given this particular table. In this various power quality disturbances are given: interruptions, under voltage, over voltage, steady harmonic distortion, etc. So voltage flicker or everything is listed here. Correspondingly, the standard number is given in this particular table for its source, effects, and mitigation. And IEEE recommended practices. So purpose of this recommended practice is to direct users in the proper monitoring and data interpretation of electromagnetic phenomena that cause power quality problems. So IEEE recommended practice defines the power quality phenomena in order to facilitate communication within the power quality community. So this document mainly IEEE power quality related documents comes under this number IEEE 1159, and IEEE 1159 is a IEEE working group that coordinates the development of power quality monitoring standards. So the existing IEEE 1159 provides general guidelines and definitions for monitoring power quality, and there are three separate task forces that are working on more uh, more specific guidelines and requirements. So that is we mentioned in the earlier slides, IEEE 1159.1.2 and point 3. I once again explaining that IEEE 1159.1 is a working group is developing guidelines for instrumentation requirement associated with the different types of power quality phenomena. So these requirement addresses issues like sampling, rate requirement, synchronization, sampling accuracy, and a number of cycle to sample, etc. IEEE 1159.2 is actually developing the characterizing different power quality phenomena. IEEE 1159.2 is characterizing the impact of power quality variations, like what is the minimum magnitude, minimum duration, phase shift, number of phases for voltage sags. So different power quality phenomena, its characteristics are defined in 1159.2, and 1159.3 working group actually focus on exchange of power quality monitoring information between different applications. So this what is the meaning is that when you are analyzing the power quality issues in a particular industry, and power quality issues are generated by particular devices, and we need to analyze the power quality problems generated by the particular device. So you can use some harmonic analysis, like you might heard about fluke. So this kind of harmonic analysis need some kind of data that should be taken from these devices. So devices, the harmonic problems are created by the devices which are developed by some other company, and we need to use some harmonic analysis which is developed by different company. So we need a data transfer method. That is, if we want to plot total harmonic distortion or waveform distortion, we need to transform that particular data into the data that is suitable to the harmonic analyzer. So such kind of format exchanging is given by IEEE 1159.3. So you can go through one such kind of format that is given as ComTrade format for exchanging wave data between fault recorders and other applications such as relay testing equipments. Any viewers who are interested in such kind of information more, you can download the particular IEEE paper regarding ComTrade format. So a more complete data interchange format is needed for power quality data, which can include harmonic spectra, RMS envelopes, characterized power quality data, and statistical power quality data, as well as the steady state and disturbance waveforms. So these things we need to analyze, and we should take all this from a particular device, and we need to transform this into a common data interchange format which is required, that will allow software developers to develop application for analyzing the power quality events and problems independently from the manufacturers of actual power quality monitoring equipment. So so if there is a common data format to analyze the power quality events, then you can use any power quality monitoring equipment to analyze or characterize the power quality problems. So these are the point regarding the IEEE standards and its IEEE recommended practices. So everyone can refer these documents. This is available in internet. You can refer all the detailed documents regarding the IEEE 1159, and all other standards are available. I have given only the introduction to the, or what is the title of all this, or what is the purpose of all these standards.